Hello everyone. So today let's solve the problem 1049 last stone weight, right? So let's see what the question states now. So this is question number 1049, right? So here we have been given an array stones. See here stones, right? So where each stone has a positive weight. So it consists of only positive numbers, right? So positive weight. So this is nothing but the stone weight. So each stone consists of the positive weight 2, 7, 4, 1, 8, 1, right? So repeatedly we have to smash two stones x and y. Any of the x and y here. Repeatedly we have to smash two stones x and y. Right. So if x is equivalent to the y, if the value of x, if it is equivalent to the y, then after smashing both will disappear. Right. Otherwise y becomes y minus x. Otherwise y becomes y minus x, right? So this is the condition, this is the criteria. Again, let me read this one loudly, just listen to this. We have been given an array stones where each stone has a possible positive weight. Repeatedly we have to smash two stones, nothing but x and y. If x is equivalent to the y, both disappear. Otherwise y becomes y minus x, right? So we have to return the smallest possible final stone weight, right? So 0 if none, 0 if none. So this is equivalent to partitioning stones into the two groups with the sums as close as possible and returning the difference. Yeah, this is fine. Yep, I just wanted to mention this point. So we have all we have to do is we have to return the smallest possible final stone weight, right? So if it is none, then we have to return 0. That also they have given in the question. Just remember that. Yeah. So here, see, we have the first example and the second example. See, we have 2, 7, 4, 1, 8, 1. First, what we will do, we'll combine 2 and 4. We'll combine 2 and 4 uh, to get 2 actually. So the array converts to now 2. So we'll remove 4 actually. From the 4 and 2, we got the difference 2, right? So this will be 27181, 27181. Then we can combine 7 and 8. Then we can combine 7 and 8, right? So to get 1, the difference is 8 minus 7, quite obviously 1, right? So this is fine. 7 and 8 will give the combination 1. So this one will be 2, 1, this one, 2 triple 1, right? So this is fine, I believe. Next, we can combine 2 and 1, right? So we can combine 2 and 1, right? So then to get difference 1, right? So 2 and 1 will combining will get the 1. So this will be 2 will be gone. So only triple 1 will be left. So next we can combine 1 and 1 to get 0, right? So 1 and 1 to get 0 is here stones are equal, right? So stones are of the equal weight. When we are having the equal weight, it gets destroyed, right? So the array converts to only one single one is left here. So then that is the optimal solution that we need to return actually. Here one, we are left with one, so we need to return one here. This is fine, I believe. Yeah, same thing goes with the example 2 as well. You can just check this one as well, the same way, in the same way that I that we discussed for the example 1, right? They have given us wonderful examples here just for the sake of understanding. Now we are having the idea on the solution, right? I mean, sorry, question, right? So now let's do one thing. Let's discuss the this one, approach followed by the complexities, and then let's write the code. First, let's discuss the approach one. Approach here. What's the approach basically? Let's go with the approach here. This one. We'll be going with a DP. Yeah. So we'll be making use of 2D DP actually to solve this particular problem. We'll be making use of 2D dynamic programming to solve this particular problem, right? So let's move on with the first point here. So let's compute the total sum of the elements that is present in the array. Let's consider first example one. Yeah. So let's go with the total sum. Let's compute or calculate the total sum. So this one will be 2 plus 7, 7, 9, 13, 13, 14, 14 plus 8, 22, 23. Yeah, this will lead to the sum equals 23 initially, right? So then what we will do, we want two groups with the sum A and B. We want two groups with a sum A and B, right? So where A plus B has to be equivalent to the S, and then minimize this one. A minus B is equivalent to this one. What do we call? S minus 2A. S minus 2A. So target best A is as close to S by 2. S by 2 is nothing but here in this case, it will be 23 by 2. 23 by 2. We'll not consider the decimal. Let's go with a 11 actually. Yeah, 11, 11.5 we'll get, right? So we'll be going with a 11, nothing but it is close to S by 2, nothing but 11 as possible, right? So now next point here will be we will be building the DP table. We have to build as per the this one approach that we discussed earlier. So we'll be going with a 2D DP. So we will be building 2D DP here, nothing but DP of ij, which is equivalent to whether we can reach some j using the first I stones, right? So this is the approach that we will be going with. Let's implement the same thing for the example one. So let's consider this one. See, now uh, we have sum initially s equals 23. S equals 23, right? So this is fine. And half is nothing but, so let me consider this one. H is nothing but half of it, s by 2, right? So half is nothing but 11. So we'll be making use of the DP to find which sums up to the 11 are attainable here, right? So this is fine. We have discussed already this one. For this particular array, sum 11 is attainable, right? Subset 7 and 4. If we consider this one, this one subset, I'll just write here 7 comma 4. So here in this case, for this array, sum 11 is attainable. Example, subset 7 comma 4. So here the third step would be, so best is a equals 11, a equals 11. Answer is, here we can just go in this way, s minus 2 into a, s minus 2 into a, right? So this one will be, s is nothing but 22, 23, right? Yes, we got 23 here. 2 into a is nothing but 11, right? 11 into 2 is nothing but 22 here. A is nothing but 11 here. 11 into 2, 2 into a, we are going. This will be 22, right? 23 minus 21 will get 1 here. So we'll get 1. So this is the output that we are going to return. This is the output that we are going to return. So this is the approach basically we'll be going with to solve this particular problem, right? So the same thing that we discussed the idea, right? The same thing we have implemented here, right? On the example one, by considering the example one. So we have got the output 1 here. So the output that we got here is 1, which is equivalent to the output that they have shown for the example one within the question. Now, as we are completely familiar with this one approach, let's discuss this one complexities part very quickly. So what will be the time complexity here? The time complexity would lead to big O of n into s, and the space complexity would lead to big O of n into s as well, right? So the time complexity would lead to big O of n into s, where s is nothing but the total sum. We have discussed this one already, right? S is nothing but the total sum here, right? So we loop n times across hop sum, right? So we'll be looping n times across the hop sum. So overall time complexity would lead to big O of n into s. Easy. Then the space complexity is n into s as well, because we'll be going with a 2D Boolean DP table as discussed, right, in the approach. Now let me delete this one. The time complexity and the space complexity for the code that we'll be writing in the future would be big O of n into s and big O of n into s respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. First, let's go with n. N is nothing but the number of stones here. So I'll just go with int n equals stones dot length. This is fine. The next part is we have to compute the total sum of all the stones. So here, let me initialize sum to 0. Let's move on with the iteration part, man. So here I can just write it in this way. For int w, this one of stones actually. So let me go with sum equals sum plus w. This is fine. The next part would be we only need to consider sums up to half of the total, nothing but s by 2 according to the approach. So let me consider here variable half, which is of the type int. So I'll just go with sum by 2. This is fine. The next part would be this one. As I've said, we'll be going with a DP, right? So let's initialize DP here. So I'll just go with a 2D DP, right? So Boolean DP 2RS, this is fine. New Boolean of, so let me give here n plus 1 along with size n plus 1 and half plus 1, right? This is fine. Now let's go with the base case. Base case is with 0 stones, we can make some 0. Yeah. So this one is fine. I can just write it in this way. DP of 0, 0 is equivalent to initially, let's set this one to the Boolean value true. Now let's fill the DP table, man. So main thing in the two, when we consider this one 2D DP is filling the DP table, right? So this is fine. So I'll just go with, so this is the iterative DP. Yeah, this is fine, man. 1 second. bottom up, right? So this is fine. This one will be int I equals 1, I less than or equal to n, I plus plus. So within this, let me go with the weight of the ith stone. So this is one base diamond. Just don't get confused. So this one will be value equals stones of I minus 1. Yeah, next let's go with a one more for loop here for int j equals 0, j less than or equal to half, and j plus plus. So this is fine. So within the for loop, let's do one thing. Let's go with the first option, nothing but don't take the current stone. So not considering the for this one current stone, right? So we have to inherit the previous row in simple terms. So I have to write the if condition for this. Just I can just write it in this way. If dp of I minus 1, previous one, right? J, then let me assign dp of I j to boolean value true. This is fine. Mm, else what we need to do, else we have to go with the option 2, nothing but we have to take the current stone if j is greater than or equivalent to value, and this one previous state allows j minus val, right? So I can just write it in this way. Just see this. See, if j is greater than or equal to val, and dp of I minus 1 here into j minus val, uh, then within the if condition, let's set the dp of ij to true. Simple. Yep. Else, else, else what we need to do, we have to set the dp of ij to false. So I'll just go with dp of ij that is equivalent to false. Yeah, let me come out of this one entirely. Let me come out of this one entirely. Yeah, now we have to find the largest achievable sum, nothing but j less than or equal to half. So this one has to be closest to the half, right? So let me go with a for loop. So this one in j equals half, this is fine. J greater than or equal to 0, this is fine. J minus minus. So what if dp of n and j, right? Uh, then what we need to do, we have to go with the minimum final weight that is equivalent to the total minus 2 into j. Nothing but in our case, we took 2 into something, right? Whatever we considered in the approach, basically. Yeah, if you remember. So this one, let me return uh, sum minus 2 into, yeah, and we considered, I think. In this case, we have to go with the j actually. This is fine. So let me come out of this one entirely. Let's go with a fallback. Fallback in the sense, this one. This shouldn't happen because j equals to 0 is always achievable accordingly with the question, right? So we have to return sum actually in simple terms. Let me return sum. Let me format the code once and let me hit the run button. So this is it for the code one. Simple one. Yeah. So let me hit the submit button. Sample test cases are getting passed, I hope. Yeah, all the test cases are getting passed. So whatever the code that we have written works absolutely correct for all the test cases, right? Yeah, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.